This is our next to last section. So this is Monday, April 20th, and we're on 12.5 Trig Identities, page 603. Now work on getting your homework in. That was 11.1 through 11.6 in the test, and then 12.1 through 12.4. So if you didn't get it in Friday, keep trying, get it in as soon as you can. And we'll keep going on here. We're almost done with this last chapter. So here we go. Example 1, determine sine squared, cosine squared, and sine squared plus cosine squared for each value of x. We're trying to establish that it always equals 1. So sine of 30 from your calculator is 1/2, and cosine of 30 is square root of 3 over 2, which we've done before. Sine of 45 is square root of 2 over 2, and cosine of 45 is square root of 2 over 2. And sine of 75 is 0.9659 off the calculator, and cosine 75 is 0.2588 off the calculator. So now when we say a sine squared of 30, it's 1/2 squared. The square doesn't show there, but it's 1/2 squared equals 1/4. For cosine squared of 30, it's square root of 3 over 2 squared. Square root of 3 squared is 3, and 2 squared is 4. And so 1/4 plus 3/4 equals 1 for sine squared 30 plus cosine squared 30. Now for 45, both sine and cosine are the same. Square root of 2 over 2 squared. Square root of 2 squared is 2. 2 squared is 4. So both sine and cosine of sine squared and cosine squared of 45 are 1/2, and 1/2 plus 1/2 again is 1. Now we saw that sine of 75 is 0.9659, so sine squared of 75 is 0.9659 squared, or 0.9330, and cosine of 75 squared is 0.2588 squared, or 0.0670. And adding the sine squared plus cosine squared of 75, we get 0.9330 plus 0.0671 equals 1 again, and it always equals that. So we see that sine squared plus cosine squared equals 1 really is our fundamental trig identity, and so we're going to go through the steps and prove it because it's so important. So given our right triangle ABC, with angle A equals x, prove sine squared x plus cosine squared x equals 1. So here we have right triangle ABC with angle A equals x is given. Sine of x is opposite over hypotenuse, A over C. Cosine of x is adjacent over hypotenuse, or B over C. That's the definitions of sine and cosine. So then we can multiply both sides by C and get A equals C sine x and B equals C cosine x by the multiply property of equality. And we can use the Pythagorean theorem to say that A squared plus B squared equals C squared. Now substituting in step 3 for 4, we have C times sine x squared plus C times cosine squared is C squared. And then c squared sine squared x plus c squared cosine squared x is c squared, power of a product property. And then we have c squared parentheses sine squared plus cosine squared equals c squared. And by the multiply property of equality, we can divide both sides by c squared, leaving us sine squared plus cosine squared equals 1. Now something we can use from time to time in our trig identities, this section, is that if we start with sine squared plus cosine squared equals 1 and subtract cosine squared, we get sine squared equals 1 minus cosine squared. And if we subtract sine squared from the original, we get cosine squared equals 1 minus sine squared. Now for example 2, use the right triangle ABC to prove that tangent x is sine x over cosine x. Well, sine x is still A over C, opposite over hypotenuse, over cosine x is still adjacent over hypotenuse, B over C, and a fraction divided by a fraction is a fraction times the reciprocal, so it's A over C times C over B. The C's cancel top and bottom, leaving us with A over B, which is indeed the definition of tangent x. Now working with the three reciprocals to sine, cosine, and tangent. We have to know these. We don't have to memorize them like SOHCAHTOA for sine, cosine, and tangent, but we do have to know the reciprocals. So secant is defined to be 1 over cosine, cosecant is 1 over sine, and cotangent is 1 over tangent. Now we just proved that tangent is sine x over cosine x, and cotangent is defined to be the reciprocal of tangent, so it's cosine x over sine x. Now on these identities, the game plan is to turn everything into sines and cosines and let it work out. So in example 3, prove that sine times secant is tangent. Sine times secant is 1 over cosine, which is just simply sine over cosine or tangent. Example 4, prove that 1 plus cosine x times 1 minus cosine x is sine squared. Well, doing a FOIL there, the first is 1, the outer is minus cosine x, the inner is plus cosine x, and the last is minus cosine x, squared x. And as we saw a minute ago, 1 minus cosine squared is indeed sine squared, what we were setting out to prove. Now for example 5, we want to prove that cotangent squared x plus 1 is cosecant squared x. So cotangent is cosine over sine, so cotangent squared is cosine squared x over sine squared x. Now with the 1, we're going to multiply top and bottom by sine squared x, so we can have a common denominator, allowing us to add the tops, cosine squared plus sine squared, our magical 1, over the common denominator sine squared x, and 1 over sine is cosecant, so that gives us 1 over sine squared is cosecant squared, which is what we set out to prove. Now the homework starts on page 606, and this is, we had already done this, sine squared of 60 now is square root of 3 over 2 squared, or 3/4. Cosine squared of 60 is 1/2 squared, or 1/4. So sine squared of 60 plus cosine squared of 60 is 3 over 4 plus 1 over 4, or 1. Now for 80 degrees, sine squared of 80 degrees is 0.9698, and cosine squared of 80 degrees is 0.0302. So sine squared 80 plus cosine squared 80 is 0.9698 plus 0302 equals 1 again. Now this is going over what we did in the examples. The reciprocals for the main 3 are cosecant is 1 over sine, secant is 1 over cosine, cotangent we saw before was cosine over sine, and tangent is sine over cosine. Now in 8, we want to show that tangent A is equal to cotangent B. So tangent A is defined to be opposite over adjacent, or A over B, looking from the angle A at the left bottom. And cotangent B, looking from the top B, is adjacent over opposite, the reciprocal of tangent, which is adjacent over opposite is also A over B. So indeed we see that tangent A equals A over B equals cotangent B. And also again on 10, we've seen that cotangent is the reciprocal of tangent, is the reciprocal of sine x over cosine x. So 1 over sine x over cosine x is cosine over sine, which is indeed cotangent. Now moving along here, remembering to plug in sines and cosines, cosine times cosecant is cotangent, or cosine times 1 over sine multiplies through to cosine over sine, which we just saw again was cotangent. And 14 cosecant times tangent equals secant. Cosecant is 1 over sine, tangent is sine over cosine. The sines cancel, leaving us 1 over cosine, or secant. Now 16 is tangent squared plus 1 is secant squared. So tangent squared is sine over cosine. So tangent squared is sine squared over cosine squared. Plus 1, we need to multiply top and bottom by cosine squared x to get our common denominator, allowing us to add the tops as sine squared plus cosine squared x equals 1. See how often we use that? And 1 over cosine squared is secant squared. Now on 18, cosecant of 60 is the reciprocal of sine. So sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. So that gives us 2 over square root of 3, which is times square root of 3 over 3 to clear out the bottom for the square roots, which leaves us with 2 square root of 3 over 3. Now secant 60 is the opposite of cosine, which is adjacent over hypotenuse. So it's hypotenuse over adjacent, or 2 over 1, which is 2. And cotangent of 60 is the reciprocal of tangent, which was opposite over adjacent. So this is adjacent over opposite. So that would be 1 over the square root of 3, clearing out the bottom, times the square root of 3 over the square root of 3 is the square root of 3 divided by 3. Now 20, cosecant times cosine squared plus sine equals cosecant. So cosecant is 1 over sine times cosine squared plus sine, and we'll have to make this times sine over sine equals, so that we can say that cosine squared plus sine squared over the common denominator of sine x gives us that 1 on top again over sine, which is cosine, which is what we were asked to prove. And 22, cotangent x plus tangent x is cosecant x times secant. So cotangent x is cosine over sine, and tangent is sine over cosine. Now we need a common denominator, and that would have to be the two bottoms multiplied together. So we're going to need sine x cosine x to be our common denominator. So we'll have to multiply the first by cosine over cosine, giving us cosine squared over sine cosine. And the next we'll have to multiply by sine over sine to give us sine squared over sine cosine. And again, we get our magical cosine squared plus sine squared is 1 over sine cosine. And remember, 1 over sine is cosecant times 1 over cosine is secant. And that's what we were asked to find. On 24, sine x times secant x times cotangent x is 1. Well, sine times secant x is 1 over cosine times cotangent is cosine over sine. Well, the sines cancel and the cosines cancel, everything cancels, and we're left with the 1. So 1 minus sine times cosine times tangent equals cosine squared. So 1 minus sine times cosine times tangent is sine over cosine. The cosine squareds, cosines cancel, leaving us 1 minus sine squared, which we've seen is cosine squared. And that finishes us for Monday. Try your best to keep up with the homework now. I really appreciate how hard you've been working. God bless you.